I will welcome everybody to our seminar this morning, and it's great to see so many of you here. This is our second year of running the Ask the Experts, and we have this year another row of illustrious panel who I'm hoping you've already come armed with some great questions, and we're going to be able to ask those of the panel. And we've put together some questions that I hope are questions we think you're asking at the moment as lab owners and maybe as clinicians. But just before we start, maybe I can just find out, can you just raise your hand if you're a lab owner, a technician, or you work in a lab? Can you just lift your hand so we can see how many lab owners are? Okay, thank you. And clinicians or people working in a clinic? Right, okay. Well, welcome, sir. Just one of you. Great, okay. So, back to our presentation then, and we're going to start really by thinking about our subject of disruptive technology. I thought it would be interesting to start with what disruptive technology might look like at the extreme, and this is not Dr. Phil Evans, our Managing Director, on one of his holiday trips. This is the NASA Space Station in 2014. You might be wondering why I put that up as our first slide. Well, it was interesting to discover that the space station in 2014 did their first 3D print. So they took a 3D printer up to space. It didn't say what brand, sorry anybody who would like to be theirs, missed a PR opportunity there. And they did a 3D print. And then this year, they did another 3D print, and they printed a 3.5 meter long pole and got a robot along with it and started constructing an antenna. I think that's as about as disruptive as you can get in terms of technology. So manufacturing in space, you may have other social, environmental and other issues with that, but in terms of an amazing leap, that was a fairly impressive step. So NASA said the ability to print everything from human body parts to works of art to rocket engines is rapidly changing the world of manufacturing. The International Space Station's 3D print has manufactured the first 3D printed object in space, paving the way for the future. And that was actually back in 2014 when they did that first print. Now, onto our team. So on our panel we have Carolyn Bra from NextDent. She is the Senior Area Sales Manager for Dental Europe. Thank you, Carolyn, for joining us today. I'll go next in row. We've got Janesh Patel. Janesh is a lab owner of an orthodontic lab in London, HM Orthodontics. Next we have Stefan Winterlink of 3D Systems. He's the Sales Manager for Dental Production. We then have Steve Watson from Exocad. He's an application specialist, and we'll be happy to take questions on Exocad and anything you might want to know about 3D design. That's right, isn't it, Steve? Dr. Phil Evans, our Managing Director at Texaram, and Phil has led for many years a milling centre, lab to lab, but of recent years has got very much involved in the area of digital workflow and how that looks for labs. And we hope you'll visit our stand as you leave. If you look adjacently across, you'll see us right there. Come and have a look at and see some of the workflow we've got. Sorry, quick plug, I have to do that. And then our own Richard Buckle. And Richard, as a 3D print knowledge specialist, spends a lot of time looking at what 3D printers there are around the world and how those work. So is it about one solution or multiple solutions? And please pose questions for him today. So, disruptive technology, revolution or evolution, and we decided we were going to set out and ask ourselves these questions. How does a laboratory who is going digital embrace change? Should labs be threatened by clinicians who are designing and manufacturing? And how do you respond as a lab? And is this the end, or is there a future with innovation in manufacturing? Well, I thought before we start the questions that the panel have seen, we'd perhaps see whether any of them would venture to try and maybe offer an answer to any of those questions. So panel, do you feel inclined to give us a thought on this? Carolyn, you look like you've actually got a thought here going on. Yeah, go for it, yes, thank you.
How does the laboratory is going to digital embrace changes? So, yeah, what I think is that laboratory and dental is a little bit conservative. So it takes that laboratory embrace new innovation. But when you see the innovation of the innovation adaptation line, then you see the early adapters and the innovators, and then the early adapters. And the innovators are 3% of the market, and the early adapters are 40% of the market. The point is that we are still in the beginning for 3D printing, or the new innovation for 3D printing, that they're gonna adapt to the market. So I think it takes a little bit of time, but I think this year or next year, many laboratories will get into this new innovation of 3D printing.
Should we use closed or open systems in 3D printing?
Yes, I can say something about that.
Okay. You're happy with this question?
Yes. So closed or open system. First of all, I want to ask you, what's the advantage of an open system?
Would anyone like to suggest an answer to that? Yeah.
Price of materials? Yes? Variations for open systems?
Send it to anyone, yeah. You can send it to anyone. Exactly.
And for closed systems, what is the advantage of a closed system? Of course, that the system is, how you say, it's a plug optimized to the printer. That's a plug and play systems. Everything is tested, but also the accuracy. You have a high accuracy. So should we close or open system? I worked a long time for NextEnd, and I worked a lot with printing companies with an open system. And I saw that sometimes it's not easy for people to optimize the materials, how you say, to optimize the materials from the printer. So I'm personally convinced that closed systems in the moment have the higher accuracy on the market. So
okay.
that.
Can we use any type of resin in my printer? So as a business, we have a range of 3D printers, and we often meet lab owners that go, well, I found this stuff online, I might as well just try and pour that in. Is that okay? So what do we think, panel? Carolyn, do you want to...
Yeah, many people think we can use any kind of resin to any kind of printer. But first of all, you have resin of 385 nanometers and, for example, 405 nanometers. And it's important to know, first of all, you have a material for printers for 385 nanometers or 405 nanometers. When you have this material, then of course you have to optimize this kind of materials. What you see, for example, with Formlabs. Formlabs is a company who used the NextEnd materials. They optimized the materials, their materials, the NextEnd materials to their printer, and they have, of course, their own materials, but it's the same material. So the point is, when you use our materials, it's not optimized, but when you use the materials from Formlabs, it's, for example, it's from their printer, it's optimized, but not our material is optimized. So you see that. So you cannot use every material to every printer. That's the facet that's the conclusion. So you really have to optimize the material to the printer.
Okay, we kind of trust NextEnd in that regard. They have the most extensive range of resins on the market available, and their knowledge is something that we certainly as a business take to note. So is now really the best time to invest in 3D printers? Again, massive question. Lots of lab owners are asking, you know, what's around the corner? Is somebody else who's brought a cheap printer out going to bring a slightly better one but still cheaper than the one I'm looking at? So when is the best time?
Yeah, I think now we start to have a good time to invest in printers because there are many companies who come into the market. We see that the price range of the printers came down. It's because also of the Formlabs. You saw before when the market where the price is about 25,000 euros, 25,000 euros, and Formlabs bring the printer market totally down. But most of the people are ready now for for new printers, and there are new technologies also. So there's a lot of opportunities outside there. And I think now it's a very good time to invest also in printers, especially because the printer prices came down.
Janesh, it'd be great to hear your comments on this. Janesh is a lab owner and actually runs a 3D printer. Do you want to tell us a little bit about your experience there?
Yeah, of course. So we invested in Structo printers last year, June. The reason we did it was the right time. We were getting questions asked left, right and centre from all our clinicians saying, when are we going to be able to print for them? So I think going into 3D printing, it was a bit of a nervous time. But you take it by the horns, and what we did was we chose what we wanted as a lab. We looked at the outlay, how much we wanted to print. We looked at the volume of prints we were doing per week, and then we decided on which printer to go for. I think that's the first steps of any lab owner or any technician, is to see how much you're going to be printing. Once you know that, there's a wide range of printers out there, but you've got to also make it specific to your needs. You don't want to be having a printer that's going to print 7 hours for 3 prints, three arches, which is going to take, it's just not production-wise. So I've also gone for the Structo, which is at the Texaram Strand, and for me it works wonders. We do 5 prints a day, 10 prints on each, 10 arches on each print, and it comes out really fast, and it's good. It's accuracy, it's speed, it's volume, it's everything that we looked for. So yeah, the 3 questions to ask when going into 3D printing is, what are your needs? Is the printer going to be able to take those needs on, and will you be able to get what you want out of it? So,
Janesh, that was great, and you didn't say anything about money there. So you didn't go for the cheapest printer, did you?
No, I didn't know.
And in your consideration, and obviously the commercial perspective is vitally important.
Yeah.
But I think if I can sort of say, you seem to observe that actually commercially productivity and efficiency and accuracy, they were your first priorities.
Yes.
Now your business doesn't have 100 people in it. You're not a ginormous lab, are you?
No. So we actually essentially only 5 people in our lab. 2 of them which are just technicians, and the rest are admin staff. But we didn't look into price. It was more, how can we provide for our clinicians? Essentially what we are trying to do as technicians is make it easier for them, because they don't have time to design things on computers, get 3D prints out. So what we looked at was our service to them. If we can provide it, then we'll go for it. So yeah, the cost wasn't the biggest thing. I think cost came after the decision was made. So to go into 3D printing, it's you've got to look at the needs first before the costs, and the costs are always constantly coming down. So it's not a big concern now.
And he still beats us up on the price of the resin regularly.
Well, you have to, right?
Good negotiator. So thank you. Okay, let's look at our next question. What do you predict for the future of 3D printing in dental? Huge question.
Yeah, what I said already, there are so many 3D printing companies, and you will see the same as the time that the milling machines entered the dental market. There were a huge of many of milling companies, and they will enter the market, but at least 5 companies survived in this market, in the milling market. You will see the same in 3D printing. There are many companies who enter the market, but at the end you will see also here about 5 companies who will survive and will stay into the market. And I think also what's important as a company, there are so many factors important in 3D printing world to survive. And I think one thing it's very important to work close, also as a 3D printing company, to work close with the software companies like Experts or 3Shape. When you don't work closely with them together, you can't work precisely. And as you know, Exocad and 3Shape are very huge companies, and they work only with big companies together. And so, yeah, at the end, companies who have a plug-and-play system and also a system what you know at the end what's coming out, they will survive.
Okay, thank you. Right, okay, let's go to our next question. Stefan, I think this is for you now. We have so many 3D printers in the dental market. How can I define which solutions are right for my application and lab? Now, Janesh, you kind of already started a little bit of that, and I saw, Stefan, you were nodding. Yeah. Has he stolen your thunder? Have you got more to tell us?
Don't worry. No, it's a clear answer. The first question is which application you want to use the printer for. You want to have it for aligner or for implant models, whatever. And when you know exactly which accuracy and which surface quality do you need, you know exactly after the volume which printer you have to use. And then in the second step is which space I have for this printer. Only for an example, when you say, okay, I want to print 50 models a day, you don't need so many space. When you say, okay, my target's in the next 2 or 3 years, I want to produce 500 a day, yeah, you have to look for another solution in this. And for sure, for end-use parts, for crowns or dentures or something like this, it makes sense to say, okay, we start with 1 or 2 applications like surgical guides, for example, and I can grow my business and my knowledge on the printer. And then the next step is in another printer or in the new latest technology, for example. That means application, volume, and the quality that you are looking for. And then you know exactly which printer is the right one. You can go for DLP, for clip technology, you can go for MJP or SLA. It's complete different range, and all these printers brings a little bit different of quality and accuracy.
Okay, thank you. It's interesting actually as well to understand whether one printer is a printer that fits all, or whether you know, do I need a rack of printers? Do I need all the same sort doing different things? Or do I actually go, well, I'll go for one SLA printer and one DLP printer and mix it up a bit? What would you suggest, Stefan?
The point is, one printer fits all. It's really complicated to answer. I think when you have a smaller lab, and you start in this business, a smaller and high flexible machine makes sense. Yeah, when you say, okay, I have a lot of, for example, implant models, you can go for one printer and they do nothing else than these models, hundreds a day, whatever, that can make sense. But to start with this business, a smaller unit makes sense, what is just a little bit more flexible. You can test, you can feel, you can, grow up your internal knowledge in 3D printing, and then that comes in the next step. I think otherwise you invest whatever on a number, and you say, okay, after a half year it was not really a good invest, and that's not the time to go that way.
How to integrate the digital and 3D printing workflow successfully into my daily business? This is a much bigger question then, actually. So you might have decided which 3D printer you want. You've now got to work out how it's going to fit. Stefan, how do I do that?
I see 2 ways, or two successful ways to implement it. First, you need a good partner, like Texaram, for example. They know the technology and they know exactly how to implement. That's the first. And the second is you have to look in your lab which application or which workflow in your lab makes the most hand job doing there. That means in which kind of work, when you need a lot of labs and so on, lab technicians, where can you terminate these handmade time? And that is the first step. Good partner, and where can I find a streamlined workflow in my lab?
This is, I think, really important because the capital investment is significant. Actually getting the return on the investment, Janesh clearly has focused on how to achieve that. And a lot of the labs that we work with, it's that focus. It's really looking commercial and not just like which one is the cheapest, which one I think will do it from reading all the blogs or whatever, which is still a good thing to do. But then can the supplier actually help work with me? And when there's problems, can they dip in and support us in doing that? And,
I have another point, sorry for that. The question is, you want to start to develop or test something, or you want to start directly with the production to be productive?
Yeah.
That is the main question in the beginning. When you say, okay, I want to start whatever, buy a cheap one, do whatever you like with it, but you can't be productive with this. When you say, okay, I want to start, sure, but I want to be productive with this machine and with this application, that makes sense in my point of view.
yeah, we if you want to buy printers from us, we can FedEx them to you. We prefer though for a technician to come down, install that, set it up, check the software's working, make sure that works properly. And I think there are other businesses that would do that, and it's making sure you get the right partner really to do that. Is the micron precision of the model really an indication of good surface quality then? So again, we see lab technicians looking under their glass, checking.
Clear answer, no.
Okay.
Sorry, I have not the examples with me, but I can show you with the same material, with the same printer, and a different micron, and the models looks like close to the same. And the point is, when you have a really rough with these layers, these models, that means exactly that the light inside of the printer is, or the material is overlighted. It's by the end a positive situation. And the layer thickness is another story. And when you have a really smooth surface, that could be that you underlight the material, that means it's swimming and it's not really accurate. It feels like good, but it's not really accurate. That means the microns say nothing about the accuracy by the end of the day, or the quality of the surface.
Moving on to CAD then, Steve, we obviously know that CAD software vitally important in the lab. Tell us a little bit about open architecture and integration.
From Execad's point of view, as a creator of dental software, one of the fundamental things for us is to be a totally open architecture. So what does this mean? This means that we have an open front end and an open export. So this allows us to work with lots of different scanner manufacturers, milling machine manufacturers, printer manufacturers. So what we do is we create a product that can be integrated. Now, as we've heard from my colleagues here, integration is not just a case of putting lots of things together and it just works. So one of the things we focus on is a very, very strong integration. So this is so that we can build in a process where we have a particular scanner, our software, then a particular milling machine or printer. And these are all designed to work together. So one of the things that the open architecture allows us to do, and it ties in with being disruptive, is to change. We can quite quickly adapt. If a new product comes on the market, a new machine, we can then integrate that into our product quite quickly. We're not stuck down a particular route with only one set of hardware. So the open architecture allows us to do that.
Did you want to say any more about this diagram in terms of that architecture? That's a good exemplar, I guess, is it, of that?
The diagram's really there just to show really lots of different, you've got computers, milling machines. I think this diagram's actually changed a little bit.
All the time.
So
It's an evolution.
I mentioned hardware, so we're talking about scanners, milling machines, printers, but also one of the other things we do within our product is allow people to implement their own libraries, particularly important with implants. So if you're designing with implants, we have lots of different libraries which cover the implant shapes, the scan adapters, also things like attachments. So this is all open to different integrators and different companies to put their product inside Exocad software. And obviously that can change, it can be added to. So it means that you're constantly allowed to change. So you're not tied into one particular route.
How does Exocad respond then to the needs of additive manufacturing? Because that's changing apace. We've heard from a lab owner, Janesh, we've heard from Nextent about their resin range. What are you guys doing to support that?
Okay, so I've just tried to explain a little bit the fundamentals of the concept of Exocad, but obviously we produce various different dental restorations throughout our design process. Some of these are becoming more and more particular to 3D printing, such as models. With models now, more so with implants as well, then we can cater to having different materials within the models. Okay, so as you can see, the model and the little pink area is a gingival mask. Okay, so this is relatively new for us, but what this does, it allows you to design a model and then to subtract that little bit of area of gingival mask. And you can print both the models, but in different materials. So the gingival mask is in a more flexible material, which is what you require for a gingival mask. You can also see surgical guides. This is something that's becoming actually more and more relevant from a planning process. And again, different materials, same thing with the partials. Partials we handle quite differently because there's a number of different processes for production of partials. Some people will print wax and cast, some people will print directly, some will mill. So all of these have different specific process workflows within Exocad. All of them workflows have been developed with people who are actually using this day to day, so it's not us inventing a process.
Yeah.
But what we're doing is taking very seriously the workflows and the routes that are needed for additive manufacture. And it allows us to take the benefits from new materials coming on the market. We can change very quickly, and we can also, as Carolyn said earlier, the parameters that are needed for certain types of resins, we can put these into the design process.
Yeah.
So once you've chosen your particular printer and your resin, we can then design to suit them parameters so that you will get the correct end result.
Great, okay. We'll move on to talk about materials now and how those fit in. We've lost one of our Steves today, so Phil has a lot of knowledge around materials, so has very kindly offered to step into the breach. I asked him about 10 seconds ago. Phil, how have you seen the evolution of full contour zirconia crowns, and what are the indications?
All right, all the labs out there, there's a question for you now. What do you think the split is between frameworks and going through to full contour? Do you see a rise in the full contour work that's coming through compared to where we used to do frameworks and porcelain edition? I see a lot of nodding heads going on in the audience. In which case, as a laboratory, do you see that as a threat, a disrupting, or do you see it as an evolution? An evolution? I agree. In which case, you've got a positive attitude to where the industry is going for the future. In which case, the skill sets that technicians have to have these days, operating with the technology, is changing. And I think if you have an open mind as a technician going forward for the future and adjust your business model, then at the end of the day, when we really go bang in the industry, because that will be led by the clinicians. At the moment, the clinicians really haven't taken up intraoral scanning to any great extent. I don't know what the percentage is, but it's not massive yet. But over the next 2 years, that will change rapidly. And as you can imagine, if you have an incoming digital file that you can take straight through to the CAD design, because you're not doing any scanning anymore, it's an incoming intraoral scan file. It means then you can design it, send it straight through to the mill, do a full contour. That then has ramifications for the milling side, because at the end of the day, you're going through to pre-shaded multi-layer discs. So it means you need a milling machine with a loader on, so it can mill overnight. And it means you massively increase your production efficiencies. But likewise, for the technicians, the skill set that you need for the future is driving much, much more towards digital, computer, CAD, CAM. And let me tell you, I mean, Richard Charnock that works for us on the CAM side, his knowledge base is just, well, it's out there. I've got a great admiration for his skill set and what he's done to take that on, because to get into the CAM side in particular is just a lifelong journey as regards what you're doing, especially once you get into designing templates. So full contour units for the future, specifically when the clinicians go through to intraoral scanning, you'll see a massive change in the demand for that type of restoration, I think.
Natural teeth have fluorescence. Don't zirconia materials suffer in varying levels?
For years, when we did frameworks and put porcelains on, the porcelains, they worked for years and years and years to get natural fluorescence into the porcelain. So of course, if you go into a disco, then at the end of the day, you're going to be there, from the old days when they used to put uranium oxide in to get the fluorescence and it went yellow, but now we put terbium oxide in and it comes out a lovely blue-white type color. We've gone now to a full contour material in zirconia. You walk into that disco and the bulk of zirconia is out on the marketplace, you're going to look like the piano keyboard. Okay, you're going to be at the black and white minstrel show on that dance floor. Not good. However, people have started using fluorescent glazes like the Emax glaze to try and overcome that problem. But what happens when it goes into the mouth and it doesn't fit properly? The dentist is going to do an adjustment, and then of course you've got black and white spots again. So 3M have obviously launched their Lava Aesthetic zirconia, and at long last 3M have come up with an innovation on full contour zirconia where the actual zirconia itself fluoresces, which I take my hat off to them. That's quite an innovation and a disruption in the marketplace. You start talking to the general public and they won't have a clue about that. It really doesn't mean an awful lot until they go into a disco, and I suppose that depends on how old they are. But
You still got it, yeah. Oh yeah. So Phil, dentists don't like removing and adjusting zirconia crowns. I think they feel like they have to get the chisel out. So why should they use them?
I don't know if you know this, but effectively there's a major difference between the old framework type zirconia, which was tetragonal zirconia, which won't mean a lot, but effectively that gave you a very high strength material to do long frameworks, two adjacent pontics, and full framework. I'm a bit nervous about still seeing full framework zirconia going in full arch. It still makes me very nervous because of what problems can go on if there's a fracture. To be honest, I'd rather see the high-tech polymers like PEEK and Pecton being used as a framework material for the future, and concentrating on where we've got the strengths on the ceramic materials in their aesthetics, their fluorescence, and putting those on as single units to the framework materials, so we're protecting ourselves for the future, as opposed to big arch cases coming back to haunt us in the future when we get a small fracture in an all-ceramic full arch framework. But what was the rest of the question, Jonathan? Again?
Yeah. Can we just bring that? It's really about removing and adjusting the
so
zirconia
getting
crowns.
back to it, sorry. When we had full framework zirconia, you go through the porcelain like a knife through butter, no problem. Obviously getting through to the framework material, for the clinicians in particular, they had to use a sintered diamond disc to go through. If they use their normal bonded diamond on the burrs at 120,000 RPM, it strips the diamonds off straight away, major problems. When we go through to the full contour materials now, with the cubic zirconia, the strength has come down to around about somewhere between 600, 800 megapascals in case of zirconia for 3M. But what it means is that material relatively is easier to machine. So for the clinicians for the future, if they've got to do endo work, for example, and go through the crown, the actual tools are there for them easily to be able to manipulate and also adjust these full contour materials compared to where we've been in the past with the higher strength materials, and they're trying to make them more translucent. We've now gone through to the cubic zirconia materials, which are much easier for the clinicians to deal with.
This is coming on to connector sizes for aesthetics then. So can you just tell us a little bit about minimal thicknesses here?
Okay. From the technicians in the room that are into doing ceramics, have you ever done full contour that you've then done a cut back on as regards the CAD side and then done porcelain addition work? Anybody in the audience done that type of work? No?
Yeah, there's a few
Yeah,
people
okay.
like that,
In,
yeah.
in which case, yeah, what we've seen as a kind of support manufacturer putting through those kind of frameworks through to the laboratories, the biggest problem is that they apply the porcelain. It gets into the hands of the porcelain technician. What's the first thing he does? He discs back into the interproximal areas and, of course, then puts a notch into the ceramic framework. And, of course, what we've got is like an old tile cutter. It either fractures in the lab, it fractures in the furnace, or the worst case scenario, it fractures in the patient's mouth. So again, to be quite honest, I would rather go full contour and do not do any porcelain addition work, just to do a simple glaze and stain, or alternatively do full framework and apply porcelain, but you've got sufficient depth with the porcelain that you're not notching back into the framework. Does that make sense?
Okay, we're just going to move on from the materials. It seemed logical then to talk a little bit then about the milling machines. And Phil, in terms of the milling machine supporting the digital workflow, of course, you know, we've been talking about materials. Tell us how that fits in.
Question back to the floor again. How many laboratories have got milling machines? In terms of all the technology that we run in our in-house manufacturing centre, Textron Technology Centre, the machines that really work day in, day out are the milling machines. Okay, and I'm sure in the future this will be the same on the 3D print side. In which case, it's not just buying a box, putting it into a laboratory and expecting it to function. It's a support, service, maintenance, backup that you've got as regards what are we going to do if the machine goes down? Because the more you become reliant on technology, you actually then realize how important it is in your manufacturing environment when it doesn't work. Okay, in which case, working with partners who are going to give you backup as regards getting files out to give you support manufacturing, and also getting the service maintenance side sorted out so that you've got support so that machine gets back up and running soon is a great thing to do. And in particular on milling machines for the future, we want to look at trying to get it into preventive maintenance. Now that's going to be a whole new ballpark, but it's research and development for the future, whereby you've got sensors on the machines picking up the vibration analysis to give feedback so that we can then start seeing, for example, when a spindle's going. And we ring up and say, look, it looks as though you're going to have a problem with this. We'd rather get in and fix it now than your machine go down. We're not there yet, but that's where milling technology is going to go. And I think also, as regards 3D print technology, from the Chicago presentation I saw from Nextent and 3D Systems, they're also beginning to put in feedback on the machines, going back to analysis, which effectively means that we should be able to give much better support to machines to continue production for the future. Does that make sense? Yeah.
So you kind of half answered this next question then about the capability of mills for a modern lab. Phil, I was thinking more in terms of the capability of how it supports operation, staffing. Can you just elaborate on that a little?
There's two ways. We as a company ran a subcontract service manufacturing centre for a long period of time, but about 3-4 years ago we realised that if we just kept on doing that, some of our key customers were beginning to look into the marketplace and decided, well, actually, we'd like to do our own production. So for us as a company, obviously, we lost a customer. So we then had the choice, really, do we then get involved in selling milling machines and obviously 3D printers now? So the answer was yes, and Jonathan and Richard have come into the business to help with that kind of evolution of our business, really, for the future, because unless we get into that technology, not just to sell a box, but to support it, then, it's quite a valid point from your business view that you're going to do your own manufacturing. Why not? I mean, if you've got the skill set, you've got the passion, and you can see the economies of scale and the production efficiencies for your own business, we had to change our business model to not just do the production, but also then to sell the equipment and do the support on the software, the hardware, and also, as I said, give backup facility if your machine goes down, so that TTC can take the strain and keep on producing for you while your machine has a problem, and we get in there and fix it. So, as Janesh says, when you're buying these machines, it's not just buying the machine, it's what happens when it goes down. What am I going to do to sort issues out? And hopefully, as a company, we're trying to, give that as a good backup for you.
Thank you. I mean, it does also, this transcends just milling and 3D printing, or also covers both of those areas, because it presents for lab owners the opportunity to not just take control of production, but then to grow the services that they can offer, whether that's by getting into milling metals, or whether that's by printing try-ins. We were talking to a lab owner yesterday about that. That was another service he could offer to clinicians, and getting a bit more creative about, well, what else are clinicians wanting that I can provide? So I keep that customer, and they keep wanting to buy more services from me, and I can grow my business. So we've got an amazing mill on display that will enable a lab owner to effectively earn money while he sleeps, because it will keep milling through the night. He sets his job up, does his design in Exocad or the software of his choice, and then on he goes, and it starts the milling for him, and or her, should I say, and then they can do that production.
Jonathan, one point, okay? Carolyn and Stefan have touched on this. When it comes to 3D printers, do not expect to buy one machine and it does everything. That is, you're just living in pie in skyland, okay? And it's the same on milling machines. When we got in liaison with the IMSI, we did that because they've got a massive range of machines, but for specific areas within your business. If you're doing business such that you're doing one specific area, there's a machine out there that will help most towards that specific production. And I think that again is key. Like Janesh said, you look at it, you analyze your business, you analyze the type of work you're doing, the volume, where you want to do the production efficiencies, and there's a machine out there that will do it. But do not expect
one machine to do everything. Yeah, we get asked time and time again on milling machines, oh yeah, I want to mill metals, I want to mill ceramics, I want to do it wet, I want to do it dry. And I said, you won't be doing it with us. Why? Because we do not want to service and maintain a cement mixer. It does not make sense. If you're trying to clean down a machine that's milled wet with zirconia and then mill metals through it, effectively it's just, what you're doing is creating for yourself a major problem.
It all comes down actually to efficiency of production. Do you want to spend your time as a high asset in terms of the business, cleaning equipment? Well, the answer is probably no, you don't. Actually, who wants to do the job anyway? So separate that out. Now, we do have some more questions, but I'm going to pause there because we want you guys to have a chance to ask some questions. So perhaps I can open that to the floor to see if anybody has got any questions that I'd like to ask any of the members of our panel, and you can select someone or just ask your question generally. Who's got a question they would like to pose to our panel? Oh. Yeah, lady over here. There's a mic roaming its way to you.
Hi. You've talked a lot about printing generally crown and bridge materials and implant based. Is anybody involved in printing dentures?
the integration between the software and the hardware, okay, and the materials is where things are at. And I'm sure you'll find out of Caroline just where the dentures are at now.
What was exactly the question? Sorry, because what you said already, it's good, but...
So my question was, you've talked a lot about crown and bridge and implant type material printing. Where are we at with denture printing?
Where we are, in a moment. Yeah, we can print, of course, dentures and also the arches, but the point is that the software is not, the workflow is not totally ready, but we're almost there. But we can, in a moment, what we do in a moment is that we print an arch and we print the single tooth and put them into the printed base. Glue them together with the material which we use also for the base. And of course, but the software, it's not totally ready to get into the market now. We have also a try-in material, but I think in a few months we will be ready.
Okay.
Can I have one question? Yes.
Yeah.
Oh.
So I'm Richard from Textram. Thanks for coming. Let's do a quick survey. Could you put a show of hands to see who's got a 3D printer?
Yeah, that's what I want to ask you.
Oh, you beat me to it.
Hands up if you have a 3D
Really?
printer.
Is that everybody, honestly?
And who is
Okay.
to attempt to have buy or open to buy a 3D printer in a daily practice?
Okay.
Okay.
So
Who is it?
three companies out of about 45 have got a
Yeah.
printer. And
Okay.
about
Half a dozen people interested
8 to 10
in
people
that,
interested.
yeah.
That's yeah.
And
Okay.
what are the questions you have? For example,
Do you have any questions
Oh, yeah, of course.
about 3D printers that you feel
are?
we've answered most of them? Awesome. You've done a great job, everybody.
And for you, for
Does that mean
example-
there's a few more questions remaining?
Just from what we're seeing when we look out at the market, we see people printing models. Well, Janesh is printing ortho, only ortho. We've got customers who are printing models and models with dies, and that's one of the biggest challenges It's getting dies that fit. People have struggled with the Form 2 printer, which is a great printer, but they struggle to get the fit. So if you want to print models on dies, we can help you with that with the Structo printer at the moment, or some other printers that might be coming soon. Surgical guide, people are starting to print surgical guide now, and they're printing at 2 different accuracies. You can do a surgical guide without drill guides, and in the software you can take libraries, can't you? You have libraries of drill guides, don't you, Stephen? In Exocad. So in Exocad in 3Shape, you can import libraries from the drill guide manufacturers, and then you can print your surgical guides and drop your surgical guides and drop your sleeves in. And then the other thing is temporary crowns as well. So this year we're seeing people who want to print temporary crowns, so clinicians. So that'll be for implants. Those are really the 3 main resins, and then special tray as well. Special tray can be printed at 200 microns, printed super fast. So if you've got a large lab and you're making special trays, then honestly you can print those so fast. I mean, probably 20 minutes they can be printed flat. So those are the main things. And what else? Can you think of anything else, Janesh?
So, yeah, in terms of ortho, we are printing everything. All our ortho work is going through 3D printers, from aligners to twin blocks to any ortho appliance. We're printing all the models through there. Yeah, so we can make removable appliances on top of those with high accuracy and speeds which are ridiculous. I'm printing every 45 minutes, 10 arches are coming out. It's fit right into my production. So yeah, it's. I just wanted to ask. Yes, sorry.
Yeah.
Are you printing the removable appliances or just the models that they go on?
No, as in we're printing models for the twin blocks.
Right.
There are actual design out there where you can actually print the model and just do a vacuum form. So it's like a vacuum form twin block appliance.
Yeah.
So there are ways around it. It depends on if your clinics are, wanting to do something different.
So you're spraying onto a printed model then and bending a wire.
Yeah. Which comes onto separations and stuff.
Could I suggest, Janesh, perhaps we can meet on the stand afterwards.
Yeah.
I've got one more last question just over there.
With all your expertise with what printer to use, what miller to use, etc., you said they're design specific. You use one for one not for another. Is there a kind of a flow chart from all your knowledge so that you can go through from start?
Richard's brain.
Use this one. Don't use this one.
Discussing with my co-director, Mr. Buckle, over there, developing such a chart. So thank you for that question and the embarrassment that he hasn't yet produced it for us. But certainly, if you genuinely want an open, objective view on 3D printers, Richard really does have a lot of knowledge on what's going on in the market and actually different types of technologies, not from a manufacturer's base, but from we want to supply equipment to labs that works for their application. That is our passion as a business, not to sell you a bit of kit that you can buy online and just get that bit of kit and hope it works, but make sure that works for what you want to do. Have a conversation with him about that afterwards, please. Our time's gone. Thank you so much, everybody, for coming. I'm Jonathan from Texaram. Come and visit our stand.